In the spring of 2019, something strange began happening in 3 areas along the Illinois River. For 6 years, Dr. Marie Holloway had returned to those exact stretches of river at the same time of year. Her team traveled by boat through waters once packed with carp, using electrofishing surveys and hydroacoustic equipment to measure their density. The data had always been so consistent that the results were almost predictable, but this time the numbers were scattered and inconsistent. Holloway assumed the equipment was malfunctioning. She replaced the devices, repeated the surveys, doubled the number of inspections, and expanded the sampling area. The results remained unchanged. Fishermen like Wade Karsten noticed it as well. He had been setting nets along this stretch of river for 19 years. Just the previous March, one of his catches had weighed nearly 900 kilograms, forcing him to dump some of the fish back into the river before he could pull the rest onto the boat. Now his final catch of the day consisted of just one 62-pound blue catfish. Wade looked at the fish and suddenly burst out laughing, the first time he had laughed in 6 months. The invasive species had once forced the United States to develop a $1.15 billion plan for its complete eradication, yet the plan had produced no results. But now, the fish were disappearing without costing a single dollar. The information in this video was cross-checked using data from the United States Geological Survey, the Illinois Department of Natural Resources, the Invasive Carp Regional Coordinating Committee, and handwritten records from people directly involved in the project. This is the Illinois River, a 270-mile waterway that flows through the fields of the Midwest before connecting the Mississippi River Basin to the system leading into the Great Lakes. For generations, the river has supported communities along its banks, carried barges loaded with grain to market, and provided fish for thousands of fishermen. Beneath its murky waters lies an important ecological corridor. During the 1960s and 1970s, the United States introduced 4 species of Asian carp, silver carp, bighead carp, grass carp, and black carp into aquaculture ponds and wastewater treatment facilities. At the time, this was considered a cheap and effective solution. Silver carp filtered algae, grass carp consumed aquatic vegetation, and black carp eliminated snails that carried parasites. But that seemingly perfect plan completely collapsed during the historic 1973 flood in Arkansas. These fish escaped into the Mississippi River system and quickly spread. By 2000, they had reached Missouri, and by 2005, they had appeared in Iowa. Around 2010, they accounted for 90% of all fish in the Illinois River, forcing native catfish, bass, and crappie to compete fiercely for survival. Another reason these fish became famous was their reaction to boat engines. When they hear the sound of a motor, silver carp often leap out of the river in huge numbers. Fish, weighing several kilograms, can slam directly into people on boats, causing them to lose control, suffer head injuries or broken bones, or damage their equipment. But these were only the visible signs of a much more serious problem to the north. Through the Chicago Canal system, the Illinois River connects directly to Lake Michigan, the gateway to the Great Lakes, which contain 1/5 of the world's freshwater and provide the main source of income for a fishing industry worth billions of dollars each year. If silver carp and bighead carp invade the Great Lakes and establish stable populations there, the damage could be permanent and enormous. The United States certainly was not going to stand by and do nothing. It turned fish removal into a recreational festival, attracting thousands of people from across the country and abroad to hunt fish for prize money. The most famous event is the Redneck Fishing Tournament on the Illinois River, founded by Betty DeFord in 2006. This unusual competition does not use fishing rods. Instead, boats startle the fish into jumping, and participants use nets to catch them in midair. Because fish weighing dozens of pounds can fly through the air like missiles, participants must wear football helmets and safety goggles. In 2010, the tournament attracted 105 boats, around 2,000 spectators, and removed 3,239 fish, which were turned into fertilizer. In 2026, the event is still scheduled to take place from July 31 to August 1 in Browning to raise funds for veterans. Each year, fishing crews in Illinois remove more than 1 million pounds of invasive carp. The fish are turned into fertilizer, animal feed, or commercially processed products. You may not know that the fish considered a disaster in American rivers are actually a familiar food in China. Silver carp and bighead carp have long been raised for food, and bighead carp heads are even used in Hunan's famous steamed fish head with chopped chili peppers. So why do Americans rarely eat them? Their flesh is white, firm, low in fat, and high in protein. But the name carp often brings to mind bottom-feeding fish, while their Y-shaped bones make them more difficult to process. Illinois therefore gave them a new commercial name, Kopi, derived from copious, meaning overly abundant. When Kopi was launched in 2022, 21 chefs and retailers committed to placing the fish on their menus or store shelves, along with 14 processing and distribution companies. In Chicago, Ina May Tavern served Kopi sandwiches. Gaijin prepared smoked Kopi, Bar 19 turned the fish into chili and sandwiches, and A Fusion also included Kopi in its dishes. Some of the catch was also shipped back to Asia. Two Rivers Fisheries in Kentucky once exported more than 500,000 pounds of processed fish to China, and in 2020, the company prepared another shipment of approximately 40 tons. An Illinois company had also been exporting frozen fish to China since 2005. However, those numbers were still far too small compared with the population throughout the entire river basin. Fishing alone also could not prevent all adult fish, juvenile fish, eggs, and biological material from moving toward the Chicago Canal system. That is why we now have the world's largest underwater electric barrier system. At Romeoville, near Lake Michigan, 4 barriers generate electric fields that force the fish to turn back. The system must operate continuously and requires backup power. At Brandon Road near Joliet, the U.S., Army Corps of Engineers is building several additional layers of protection, including electricity, underwater sound, a bubble curtain, a specially designed channel, and a flushing system. This project alone is estimated to cost about $1.15 billion. But did that enormous investment deliver victory? No. In late 2009, silver carp DNA was detected above the barriers, including in the North Shore Channel near Lake Michigan. Fewer than 5% of the samples tested positive. Nearly 2,000 yards of netting were deployed in the CalSag Channel, but no live carp were caught. As a result, government agencies still have to hire commercial fishermen and conduct year-round monitoring. Even expensive, large-scale projects can only reduce the risk. They cannot guarantee complete eradication. It was not until 2019 that, as you saw at the beginning, the number of carp suddenly began to decline noticeably. When sonar showed that carp density was falling, Holloway conducted environmental DNA testing, a method that can detect the presence of fish simply by analyzing water samples. The amount of carp DNA in the water column was decreasing. That meant the actual number of fish in the river was also declining. Holloway then installed underwater cameras at all 3 locations. What those cameras recorded over the next 4 months changed the way scientists thought about controlling invasive species in the United States. 3 native predators, once pushed close to extinction during the 20th century, were quietly making a comeback. They were accomplishing what helicopters, electric barriers, and commercial bounties had all failed to do. The first species to draw attention was the blue catfish, scientifically known as Ictalurus furcatus, a native species of the Mississippi, Missouri, and Ohio River basins. It lives in large rivers and uses the sensory barbels around its mouth to locate food in murky water. The USGS reports that blue catfish can grow to around 1.65 meters long and weigh between 40 and 50 kilograms. In some stretches of the upper Mississippi River, this species once declined because dams blocked its seasonal migration routes, while fishing reduced the number of large individuals. However, recent surveys in Missouri show that many populations in major rivers currently remain relatively stable. The most notable evidence emerged at Ellis Bay, near Alton, Illinois. From 2013 to 2014, researchers collected 65 adult blue catfish, measuring between 567 and 1,020 millimeters in length. Of the 53 fish that had food in their stomachs, silver carp appeared in nearly 70%, accounting for about 58% of all prey items and nearly 60% of the total dry weight of their diet. Big head carp were also found, but appeared in only about 3.8% of the stomachs. If you have ever cleaned a 60-pound blue catfish, you will understand what is now being found inside their stomachs. A cut is made behind the pectoral fin, and then the skin is peeled away in one long, pale sheet. When the abdominal cavity is opened, what appears is no longer crayfish or freshwater shad, as it once was. Instead, there are 2, sometimes 3, partially digested juvenile silver carp lying one after another inside the stomach. That is what people are now finding inside blue catfish. But the findings also revealed a more complicated issue. Many of the silver carp found in the stomachs were larger than the size of prey the catfish could swallow whole. The research team therefore suggested that the catfish may have eaten dead or injured fish, rather than actively ambushing and swallowing every one of them. But blue catfish still could not explain why adult carp weighing 6 to 7 kilograms were also disappearing. Silver carp and bighead carp usually feed near the surface, while many native North American predators hide near the bottom before suddenly surging upward from the darkness. After decades of decline caused by dams, fishing, and habitat loss, these predators are gradually returning, and the carp, which evolved alongside a different community of predators in Asia, seem unable to recognize the danger coming from below in time. So which species is powerful enough to take down a fully grown carp? It was the alligator gar. This is one of the oldest lineages of fish in North America. Its ancestors appeared more than 150 million years ago. An adult can grow longer than 2.4 meters and weigh more than 136 kilograms. The U.S. record reached 327 pounds, nearly 148 kilograms. Its body is protected by hard, armor-like ganoid scales, while its modified swim bladder allows it to rise to the surface and breathe air in oxygen-poor waters. But like many other species, alligator gar were heavily overfished during the 20th century and lost many of the wetlands they needed for reproduction. In Texas, wildlife officials once deliberately used electricity to kill them because they believed gar preyed on sport fish. Later research showed that their diet mainly consisted of common species such as freshwater shad, buffalo fish, freshwater drum, and carp. Bass and catfish made up only a small portion, and there was no evidence that alligator gar reduced sportfish populations. By the 1960s, alligator gar had disappeared from Illinois waters. Biologists later raised young alligator gar in hatcheries using broodstock collected from the lower Mississippi River, then released them into the waters of southern Illinois that their ancestors had once dominated. From 2010 to 2025, biologists released more than 21,000 alligator gar into dozens of bodies of water across the state. They tagged the fish, they tracked them, and year after year, the giants began returning to the river that had forgotten them. The people leading this work have been extremely cautious, and honesty requires us to be cautious as well. Unlike catfish, which must swallow their prey whole, the alligator gar is an ambush predator. It lies motionless near the surface, slowly approaches, and then suddenly snaps its broad jaws, lined with 2 rows of teeth, around a passing fish. The Missouri Department of Conservation considers it one of the few native fish large enough to help control invasive carp. This is a living member of an ancient fish lineage that first appeared around 150 million years ago. Its long, olive-green body and dorsal fin, running along most of its back, make it look like a creature from prehistoric times. Bowfin usually measure between 38 and 69 centimeters long, but large individuals can exceed 1 meter. Like gar, they use their swim bladder as a primitive lung, allowing them to survive and hunt in oxygen-poor swamps, small creeks, and stagnant waters. Ironically, many anglers once considered bowfin a trash fish because they believed it preyed on valuable sport fish. In some places, the fish were killed and left on the bank. But we were wrong about this species as well. Bowfin are not destroyers of sport fish populations, but predators that help maintain ecological balance. They usually feed on the small fish that are most abundant in their habitat. Therefore, in quiet waters now filled with juvenile carp, the invasive fish are increasingly becoming a natural part of their diet. This living fossil, hidden in the shadows of the swamp, has quietly added the river's newest problem to its ancient diet. In this way, a predator pyramid is forming within the river. Bowfin consume larvae in stagnant waters, blue catfish hunt juvenile carp in the water column, and alligator gar target adults near the surface. The 3 species attack 3 different stages of the carp's life cycle, from hatching to reproduction, reducing new generations, limiting adult populations, and gradually closing off the carp's pathways to survival. But you know what? This phenomenon is not limited to the Illinois River. On the other side of the Pacific, common carp have invaded large areas of Australia's Murray-Darling Basin. At some locations in New South Wales, they account for nearly the entire fish biomass. Yet beneath those waters, there is still a native predator large enough to attack them: the Murray cod. The Murray cod is the apex predator of Australia's inland rivers. This fish can grow up to 1.8 meters long and weigh more than 100 kilograms, but it is currently classified as vulnerable because of population declines and habitat degradation. In the early 2000s, ecologist Brendan Ebner worked with anglers in the lower Murray River region to investigate what Murray cod actually eat. The digestive tracts of 39 fish were examined, and the results surprised many people. About 35%, or nearly 14 fish, had carp in their stomachs. Every Murray cod that had eaten carp was more than 500 millimeters long. Fish also accounted for more than 90% of the total food mass found, confirming that Murray cod are apex predators capable of handling prey, weighing up to about 1 kilogram. The FRDC also reported that carp measuring up to 410 millimeters had been found in the stomachs of large Murray cod. However, this detail came from an expert observation cited by the FRDC, not from a case fully documented in the scientific paper. Returning to Illinois, studies show that the entire native fish community in the Illinois River is gradually beginning to use invasive carp as a new food source. After a major spawning event in the LaGrange Reach in 2014, researchers captured 1,472 native predatory fish and examined their stomach contents. Juvenile carp made up only about 9% of the available prey fish, yet they appeared in more than 15% of the diets of 11 species, including white bass, largemouth bass, smallmouth bass, black crappie, white crappie, channel catfish, flathead catfish, yellow perch, freshwater drum, yellow bass, and short-nosed gar. Most notably, white bass, black crappie, and short-nosed gar continued selecting carp even after the number of juvenile carp in the environment had declined. This is a form of biological resistance. The native community limits an invasive species through predation, competition for food, competition for habitat, and other natural pressures. But this does not mean the river can now solve the problem on its own. This ability only reduces the success of the invasive species. It does not guarantee their complete removal. Carp still have a major advantage. A female silver carp can produce between 145,000 and 5.4 million eggs, while a bighead carp can lay up to about 1 million eggs each year. Juveniles are vulnerable to predators during most of their first year, but they grow quickly. Once they become too large for many predators to swallow, natural predation pressure declines significantly. The river has not completely eliminated the invader on its own, but it is gradually restoring predator-prey relationships that had once been weakened, while humans are reducing carp numbers faster than the fish can move north. After more than a decade of using multiple control measures, the clearest results finally appeared in the upper reaches of the Illinois River, near the waterway leading toward Lake Michigan. Carp have not disappeared from the entire river, but their density at Starved Rock, Marseille, and Dresden Island has fallen sharply. What caused this change? It was not a single barrier, a fishing tournament, or one mysterious predator. Illinois hired commercial fishermen to remove carp year-round, focusing on taking out adult fish before they could move farther north. Each year, more than 1 million pounds of invasive carp are pulled from these three areas. In 2023 alone, about 1.7 million pounds, equivalent to more than 770 metric tons, were removed from the state's waterways. After 13 years, the IDNR reported that carp density in these upstream areas had declined by nearly 95%. But fishing was only one part of the effort. Dams and navigation locks slowed the fish's movement. Electric barriers prevented them from approaching Lake Michigan, and sonar, tracking equipment, and environmental DNA helped detect individuals that slipped farther north. USGS models show that reducing the number of fish moving upstream from lower sections, combined with capturing those that have already reached the front line, can significantly reduce upstream populations. Nature also added pressure as bass, catfish, and many other native species began eating juvenile carp. However, there is still no evidence that the recovery of predatory fish was the main reason the carp population declined. The battle against invasive carp in the United States is still far from over. In the lower Ting, the Illinois River, their population remains extremely large. But near the front line leading toward Lake Michigan, their density has fallen sharply thanks to the removal of millions of pounds of fish each year, the electric barrier system, environmental DNA monitoring, and continuous containment efforts. In the future, the Brandon Road Defense System, valued at more than $1 billion, will add underwater sound, a bubble curtain, electricity, and powerful flushing currents to reduce the risk of fish reaching the Great Lakes. At the same time, scientists continue studying the roles of catfish, bass, gar, bowfin, and the entire native predator community. But the most important lesson is not about finding one fish species capable of eliminating all the carp. An ecosystem cannot be saved by a single weapon. It requires technology, controlled fishing, habitat restoration, and native species that humans once underestimated. What do you think? Should the United States continue investing in massive containment structures, or should it focus more on restoring native predators? Share your opinion below, and subscribe to the channel to follow the next incredible battles to restore ecological balance.